Good morning to all of you. Today we are going to discuss about Fresnel diffraction at straight edge. So this is the figure which represents the diffraction through the straight edge. This xy is the straight edge, one edge xy. So here this one, suppose it is A or B is the wavefront which coming from the source S, and this AB wavefront when striked with this XY edge, then diffraction pattern has been observed on this screen. This is the screen. Here the edge is kept at a distance A from the source, and the screen is kept at a distance x from the edge. This is the x, small x, and here xy is the capital X and y. So now this wavefront when striked with this xy edge, what type of assumptions with the help of Fresnel's diffraction, or what are the Fresnel's assumption that we can consider? Here we can see that, or previously we have been saw that when a plane wavefront like this will be striked with a slit, then this wavefront has been divided with numbers of half period zones. This is one half period zone, this is another half period zone, this is another half period zone, numbers of half period zone, and the ray coming out from each and every half period zones and their superpositions at the particular point on the screen is going to be decide about the diffraction intensity or bright or dark fringe. So as per the Fresnel's assumption, any wavefront is going to be divided with numbers of half period zones. So here suppose this wave front, that is AB, whatever we have been considered for this case, when striked with the edge, straight edge XY, this wavefront AB can be divided into numbers of half period zone like this, numbers of half period zone. So same thing it has been written here. Consider a sharp edge XY placed at a distance A, small a, from the source. Whatever we have been discussed, XY is the edge kept at a distance A from the source. Here X refers to the pole of the wavefront with respect to the point O on the screen. If we are going to consider the point O, then the X is the point which can be called as pole. That means if we have to consider the wavefront is AB, and here I can represent this is the wavefront and this is the X position and this is the Y position of the straight edge, then this point, this middle point, or this point where the wavefront's middle part is going to be touched with the edge will be called as the pole, and it has to be straightly joined to the screen O like this. So this X point will be called as the pole. X, small x, is the distance from the edge to the screen. P is any point on the screen which is at a distance y from O. The intensity at point P depends on the number of half period zone from x to q. But in our previous class we have been discussed that the intensity at point P will be depends on the number of half period zones of the wavefront, or what are the zones that we have to be consider on the wavefront through which the light has been passed through and is going to be collected at the point P. So at the point P on the screen, if here is the screen will be present, at point P the resultant intensity depends upon the number of half period zones. In this case, in our straight edge case, here we can see that below this straight edge or below this point X, this much wavefront could not be considered for the intensity of the point P. That means this much portion of the wavefront could not contribute to the variation of the intensity at point P. So hence the intensity at point P depends on the number of half period zone from X to Q. That means above X, whatever the wavefront will be, that wavefront, this much, from A to X, this wavefront is going to be only transmit towards the screen. But this wavefront, BX wavefront, is going to be obstructed by this edge. So the intensity at point P will be decided by this wavefront only, because this wavefront, that is AX wavefront, is transmitted and this XB wavefront has been blocked. So only for that the intensity at point P depends on the number of half period zone from X to P. Now if this wavefront A to X or X to A wavefront is traveling towards the screen, then obviously we have to consider the number of half period zones will be present in this wavefront, because this wavefront already blocked. So we have to consider only the half period zones which will be present in this portion of the wavefront. So because according to Fresnel's assumption, the wavefront is nothing but the wavefront is nothing but the portion which can be divided into numbers of half period zones for the mathematical calculation. This is the Fresnel's assumption. So as it is Fresnel diffraction, so we have to consider the so-called half period zone, whatever present in between A to X wavefront, that half period zone, or due to that half period zone, we can get the variation of intensity or intensity at the point P, resultant intensity at the point P. So on the wavefront AX, whatever the half period zone has to be considered, and BX wavefront is not going to be considered because it is blocked by XY. So now the path difference between the two optical rays, that is XP and QP. Now if we want to find out the intensity at the point P, then we have to consider two rays, that is XP and QP, which are the two rays are coming from the wavefront AX. One is XP and another is QP. So the path difference between the two rays will be decide the intensity at the point P. So now the path difference between these two rays will be calculated by considering the triangle XPO. From the XPO triangle, XP is nothing but X to P is nothing but this distance plus this distance to the power √, or √, of this distance square plus this distance square. up to this distance x to O is the distance x square y square. That means xp is nothing but root over of x square plus y square. So xp is equal to x root over of x square plus y square. Now the path reference will be this one minus qp. The qp is nothing but here qp is nothing but sq plus qp, or we can say that s to p minus s to q. Okay, so here s to q is equivalent to a. Okay, so now q to p will be s to p minus a. So s to p will be equal to this much x plus a square. Though here s to p will be distance of how much? A plus x square plus y square root over. Okay, same thing it has written that s to p is this much and q to p is nothing but sp minus sq, that is the sp we found this one minus sq is that much a. Okay, so here sp is nothing but a plus x square plus y square to the power 1 by 2 minus a because here sq is approximately a. So now applying binomial theorem. The binomial theorem, we know that 1 plus x to the power n will be equal to 1 plus nx plus n into n minus 1 by 2 factor x square plus n into n minus 1 into n minus 2 by 3 factor x cube plus dot 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 like this. Now for this equation we have to consider the binomial expansion or binomial theorem, that the path difference will be x. I have been considered, or we have been taken x outside, then it will be how much? 1 plus y square by x square to the power 1 by 2. Then 1 plus y square by x square, y square by 2x square to the power 1 by 2. If we have to consider the binomial theorem, then it will be 1 plus y square by x square to the power 1 by 2. If I am going to consider binomial theorem, it will be 1 plus y square by 2x square plus n into n minus 1. Here n is 1 by 2. Okay, here n is 1 by 2. 1 by 2 into 1 by 2 minus 1, like this, divided by. So if we are going to consider, see here I written directly. Here one step it is not written here. So from this term we can find, if x square is going to take outside, it will be 1 plus y square by x square to the power 1 by 2. Okay, this is going to be expanded by binomial, by considering binomial theorem. X square, it will be 1 plus 1 by 2 y square by x square plus n into n minus 1, that is 1 by 2 into 1 by 2 minus 1 into y to the power 4 by x to the power 4 by 2 factorial, like this. Okay, but we are not going to be consider the higher order term of this, because y is very small and x is larger as compared with y and x. Y is small and x is large. So if x is large and we are going to consider the higher term of x, then this whole term is going to be decreased as compared with this one. So only for that we have been consider half y square by x square, and other higher terms we are not going to be considered. So it will be 1 plus y square by 2x square minus here also 1 plus a plus x is going to be take outside. Then we can found that 1 plus, if I am going to take this one outside, then it will be a plus x, then it will be 1 plus y square by a plus x square to the power 1 by 2. Okay, then we have to apply the binomial expansion for this term. We can found 1 plus y square by 2a plus x square, and other terms we going to be neglected, and then last term is minus a. Okay, so del equal to x plus y square by 2x, x is multiplied here, minus a plus x minus y square by 2 into a plus x plus a. So del equal to, we can found y square by 2 into 1 by x minus 1 by a plus x. Okay. Now at last we got del or path reference equal to y square by a by 2x into a plus x. So this path reference, if we are going to be equate with the conditions of bright fringe and dark fringe, then what we are going to get? Come to the next page. Whatever we are going to get, that for maximum intensity at point P, the maximum intensity can be found at point P will be when the path reference will be 2n plus 1 lambda by 2. Here 2n plus 1 lambda by 2. Why? Because in our previous maybe you have remembered that for first half period zone it is considered as positive oscillation, next half period zone that is opposite, then third one is positive, then fourth one is opposite. So the first one, third one, the odds one is creating the maxima at the point P. Whenever we have been discussed with at the time of rectilinear propagation, you just recall that one. So at the time of discussion of rectilinear motion, we consider that M1 is oscillating in this way, M2 is oscillating this one, and at last we got the intensity or the resultant intensity is nothing but M1 square by 4. That means the resultant intensity depends upon the odd half period zone's amplitude. So hence odd half period zone amplitudes means here the path reference should have to be odd multiple of lambda by 2, that will be 2n plus 1 lambda by 2. Here n equal to 0, 1, 2 like this. Okay. So here del we found that yn square for any n. In general we found that del equal to y square by a 2x into ax. For a particular value of n, it can be written as yn square into a by 2x into a plus x. So hence yn square a by 2x into a plus x will be equal to 2n plus lambda by 2, and yn equal to this much. Here yn can be found as 2n plus 1 root over, that is proportional to 2n plus 1 root over. Likewise for minimum intensity condition is path reference should have to be n lambda. N lambda means here we have been considered that the even half period zones are going to be create the minima at point P. So path reference we found that yn square into a by 2x into a x plus a equal to n lambda, yn equal to this much, and from this expression we can find yn is proportional to 2n to the power 1 by 2, or it is proportional to root over of 2n. So here we can conclude that from this expression yn proportional to root over of 2n plus 1 and yn proportional to root over of 2n, from these two expressions we can find that with increase of n order, the bands or fringes get closer with each other. That implies width decreasing gradually from 0 to P. That means here if we are going to move from 0 to P, the intensity will be like this. Here this intensity distribution is from P, from distance from 0 to P. That is, suppose it is like this, 0 and towards P. If we are going to move, suppose P will be here, then the distribution of intensity will be like this. That means at O, or if we have to move from O to this side, we can get like this intensity. Here also we can get intensity like this. like this. So if we have to move O towards P, the intensity is going to be decrease. Okay, so maximum we can found nearby O, and at point P the intensity will be decreased and the fringes is going to be close with each other, because yn is nothing but proportional to 2n. So if we are going to consider y1, if we are going to consider this one, yn is proportional to root over of 2n, y1 equal to 1.41, y2 equal to 2, y3 equal to this much, y4, y5. The difference between y2 and y1 equal to 0.59, y3 and y2 0.44, y4 and y3 difference 0.38, y5 and y4 0.34. We can see that the difference is decreasing, means fringe width decreasing as we are increasing the n value 1, 2, 3, it is increasing, and difference between the fringes also decreasing. Same way we can also found that the decreasing of fringe width. So hence we found that the intensity distribution from the point O towards P will be like this, it will be like this. It will like this. This intensity distribution I have been represented here, that is from distance from O to P. If we have to move from O to P, the intensity distribution will be like this. So this is the explanations of diffraction at straight edge. Go through this with your note and clear and complete it. Okay.